Hi students, in previous video we discussed collision resolution techniques. What are different collision resolution techniques present in the hashing? That means how to resolve collisions. The list we discussed. Now one by one, each one we will discuss in this video. Firstly, we will discuss the first collision resolution technique, separate chaining. So now, what is this separate chaining? So how the elements are inserted in separate chaining. So now separate chaining, the name itself specifies the data is stored in the form of chains, and these chains are separate. What does it mean? So the elements which are mapping to the same address are stored in the form of a chain. So now separate means, so the chain is maintained for the mapping address 0 elements. The chain is maintained separately for mapping address 1 elements. The chain is maintained for mapping address 2 and so on. So separate chains are maintained for the mapping addresses. So for the elements which are having the same mapping addresses. So that's why the name here it is called as separate chaining. The data structure used in separate chaining is linked list. So here the data is stored in the form of a chain, no? So the data structure used in separate chaining is linked list. So now here the hash table size, based on this hash table size, so here header nodes are maintained. So that means the number of header nodes is nothing but your hash table size. Generally, header node, what is meant by header node? Header node is a node which stores address of first node, which stores address of first node, which stores address of first node. Okay, so like that here in the hash table of a separate chaining technique, assume our hash table size equal to 10. Then how the hash table is represented in separate chaining? So in separate chaining, hash table size is 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the hash table. Hash table size is 10. That's why 0 to 9 are the mapping addresses. 2, 1 and 0. And all these are head nodes. So you know the head node is represented with a node which consisting of 2 partitions. So the first partition is the data partition and the second partition is the address of next node. If you don't have any idea of linked list, please see the linked list concept I explained in the video single linked list or double linked list. You can see any one of these videos. Then it is easy to understand this one. Okay. In linked list, especially in single linked list, and the node is represented like this, consisting of 2 partitions. One is data partition and second one is address of next node. Okay. So like that here also all these are head nodes. So node is divided into 2. Node is having 2 partitions. So that's why 2 partitions here we are maintaining. Again 2 partitions, 2 partitions, 2 partitions. Initially there are no elements. That's why the next pointer is, that means no nodes are present. So that's why the next node is a null pointer. Like that, initially the hash table is represented in separate chaining. Okay. So now how can we perform the operations? like insertion operation or deletion or search operation. So everything I already mentioned depending on the function, hash function, which is equal to key modulus hash table size. Based on this, we will perform insertion operation. So based on the mapping address you will get, so we will insert a node. So how can we insert? So consider an example. Now the elements are 10, 18, 16, 14, 20, 21, 38. For example, these are the elements. Now how can we construct the hash table? So the hash table, consider the hash table size as 10. Consider the hash table size as 10. See here I am representing the hash table. So hash table size is 10. So 0 to 9, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and these are the head nodes. That's why it is divided into two partitions. Now see, first one, h of 10. So h of 10 equal to 10 modulus 10 equal to 0. That means 10 is inserted in which bucket? 0th bucket. How do we insert? Actually all these are water. All these are null pointers. Okay. Now 10 we want to insert. 10 is inserted in the 0th position as hash function we are getting 0. So how can we insert 10? So now this is the node. The to 10. This is the head node. Store the or give the link between that new node and the head node. That new node's next equal to null pointer. Why? Because no next nodes are present. Okay. Next element 10 completed. Next h of 18 equal to 18 modulus 10, which is equal to 8. Now come to 8th bucket. So 8th bucket here again allocate memory dynamically for this new node. I already mentioned, if you have not seen my linked list video, please watch that video for better understanding. So here 18 and the next pointer is none. So 18 completed. Next is 16. H of 16 equal to 16 modulus 10, which is equal to 6. So that the 16 is inserted in the 6th bucket. So 16 completed. Next 14. H of 14 equal to 14 modulus 10, which is equal to 4. So now 14 is inserted in the 4th bucket. Okay. Now next 20. H of 20 equal to 20 modulus 10, which is equal to 0. But 0th bucket already consisting of one node. Then how can we insert? So this new node you can insert at the end or you can insert at the beginning. Okay, but better to insert at the beginning without moving pointers. So here I am inserting 20 at the beginning. So now insert a new node at the beginning. Okay, now allocate memory here. So what is the element we want to insert? 20. Insert the data 20 and give the link between these two. Now this link will be broken up. That means here the elements present are 10 and 20 and 10. Okay. Next 21. 21. H of 21 equal to 21 modulus 10, which is equal to 1. So inserted in the first bucket. 21 null pointer. Next h of 38 equal to 38 modulus 10, which is equal to 8. So here also 8th bucket consisting of one node. This 38 where we will insert at the beginning. So allocate memory dynamically like this and insert the data 38 and give the link. So I already discussed this one in single linked list, how to add a node in linked list. Okay. So like that the insertions are performed. Now the final hash table we will represent here, or we will represent now final hash table here I am representing. So hash table size is 10. This is head node. That's say 2 partitions 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So now the final hash table is, so here first element is 20 and the next element is 10. Next, in the first bucket 21, fourth bucket 4, sixth bucket 16, eighth bucket 18, not 18, first one is 38 and this is 18, null pointer. So now in the remaining head positions, next pointers are null pointers, don't forget to represent. This is your final hash table using separate chaining technique. This is separate chaining technique. Okay, hope you understand, students. So how to construct a hash table by using separate chaining. So here we are resolving collisions. Then what are the advantages and disadvantages of this separate chaining? So now we constructed this. So now what are the advantages? See, here there is no case of collisions. There is no case of collisions. Why? Because here you can insert, suppose 30, 40, 50, you can insert here in the form of a chain. Here also you can insert the mapping addresses, whatever you are getting, the mapping address as 4. Like that, there is no case of collision. So you can insert how many elements you want to insert, you can insert. So no collisions. Okay, so that is the main advantage. And it is, memory will not be wasted. Memory wastage is not there. Why? Because it is using pointers, dynamic memory allocation. So it is using pointers concept and using the functions malloc for allocating memory. After usage is completed, you can use the free function. So memory will not be wasted in separate chaining concept. Now these are the advantages, main advantages of separate chaining. Then what are the main disadvantages of the separate chaining? So pointers and using all this, so then occupies more memory, occupies more memory, and you know pointers, whenever you are using linked list, we are using difficult to implement, So these are the main disadvantages of separate chaining. So to overcome these disadvantages, so we are going to discuss another hash function, open addressing, which we will discuss in the next video. Hope you understand, students. If you have any doubt, please send a message in the comment box. If you like the video, please share with your friends and subscribe the channel. Thank you students. Have a great day. Bye.